Hi, my name is Ghazal and I'm a PhD student at UGhent, and today I would like to introduce you to one of my recent works. The lymphatic system is a network of converging vessels dispersed all over the body. It regulates the immune responses and collects excess fluid from the tissue, maintaining homeostasis. Compared to the blood vascular system, the lymphatic system is not a closed circuit and it does not have a central pump. In order to compensate for that, the collecting lymphatic vessels consist of small contractile segments called lymphangiones, which are situated in between unidirectional valves that prevent backflow. Disruption of lymph transport may lead to lymphedema, which manifests itself by excessive swelling of the extremities. Unfortunately, at the moment, there is no long-term treatment for it, and our lack of comprehensive understanding of lymph transport is a contributing factor to that. With that in mind, we decided to develop a model of lymph propulsion. To acquire the morphology of the lymphatic vessels, we first injected the contrast agents into the interstitium and then visualized it using high-resolution micro-CT. We then segmented and 3D reconstructed the resulting images, giving us this popliteal collecting vessel. We then take a segment of the vessel, and to give you an idea of the dimensions of the model we'll be working with, the total length of this vessel is 2 millimeters, with its diameters ranging between 50 to 130 micrometers. This small collecting vessel segment is made up of 3 lymphangiones in series, and the collecting vessel is placed in a prolastic interstitium. The lymphangiones are separated by one-way valves, which switch in between closed and open states depending on the pressures in the vicinity of the valves. There is no pressure gradient between the inlet and the outlet of the vessel, and as a result, the lymph propulsion would be only the consequence of sequential lymphangiome contractions. Here you see an example of these contractions with the colors representing the level of displacement of the vessel wall. We then performed a parametric study, and the 2 parameters having the most impact on lymph propulsion were determined to be the valve resistance in the open state and the elastic modulus of the interstitium. Too low valve resistance will cause leaking valves, which can be a cause for lymphedema, and a too high elastic modulus of the interstitium will limit the deformation of the vessel wall, which can be a consequence of lymphedema. Thank you for your attention. If this topic interested you or you have further questions, please reach out. I'd be happy to hear from you.